Hello everyone, I hope you are doing well. So today I am pleased to present LebonPrix, an end-to-end machine learning system designed to predict rental price across France. This project integrates the entire data lifecycle from collection and cleaning to modeling, deployment, and business visualization. So this is the overall architecture. So it's composed of 5 main components. The first one, data collection and transformation, where raw data is gathered from Leboncoin.fr. Second thing, we have predictive modeling, where we build and compare regression models. Third, model deployment using FastAPI microservice. Fourth, an application layer built with Spring Boot and React Native to serve prediction to end users. And finally, a business intelligence layer developed with Power BI to visualize insights and monitor results. LebonPrix demonstrates how machine learning, software engineering, and data analytics can come together in one coherent system. So now let's go in details in each part. So the first notebook is for scrapping the data using BeautifulSoup. So we used BeautifulSoup to scrap the data, really state listing from Leboncoin.fr. So we extracted structured attributes such as city, price, number of rooms, and so on and so forth. So the collected data then is then processed through a Medallion architecture, a layered data engineering approach inspired by the modern lakehouse pattern. So in the bronze layer, or raw data, we store the scrapped data in CSV format exactly as extracted. In the silver layer, or transformed data, we perform cleaning, normalization, and future engineering using pandas. And finally, in the gold layer, or business data, we enrich the dataset by applying business rules and preparing the futures for modeling. So this structured approach guarantees data quality, traceability, and scalability, making the downstream analytics more reliable. Coming now to the model development. So once the dataset is ready, we move to model development. So several regression algorithms we are tested: linear regression, polynomial regression, Lasso regression, and the extension of regression like Lasso, Ridge, polynomial with Lasso, polynomial with Ridge, neural network also, and XGBoost. Each model was evaluated using MAE, RMSE, and R-squared metrics. So among all tested models, XGBoost achieved the best balance between accuracy and efficiency with MAE 205, RMSE 289, and R-squared. So this model captures nonlinear relationship while maintaining fast inference, which makes it ideal for deployment in a real-time application. And after tuning its hyperparameters, we serialized the final version as an XGBoost model.pickle for production use cases. So the trained model is deployed through a FastAPI service, a modern and high-performance Python framework for building APIs. So the XGBoost model, or the best model, is stored here in this folder model. So we have those scripts. We use those scripts to build the FastAPI service. So we have the model loader.py to load and catch the serialized model. Then we have preprocess.py, ensure inputs data consistency and encoding. We have then schema.py, or schemas.py, defines pedantic models for data validation. And finally, we have the mean.py to launch or to expose prediction and endpoints through REST APIs. And this is the endpoint. So the service receives JSON request, applies preprocessing, perform inference using the XGBoost model, and returns the prediction or the predicted renter price. This microservice acts as the intelligence layer of the LebonPrix ecosystem. Coming now to the mobile application. So to make the system accessible to users, we developed a Spring Boot backend and a React Native mobile application. The Spring Boot layer acts as an intermediary between the FastAPI model and the database. It receives HTTP requests from the mobile app, forwards them to the FastAPI endpoint for prediction, and stores each prediction together with user input in a Postgre database. And we can see that in this slide. Exactly. So here we have the Spring Boot application. which acts as an intermediate layer between the user and the FastAPI service. So basically, the Spring Boot service, it receives HTTP requests from the mobile app and then forward them to the FastAPI, get the prediction price and send it back to the user, and also store the data entered by the user and the predicted price in a PostgreSQL database for later analysis using Power BI. So the backend follows a layered architecture, as you can see here, with controller, service, repository, and entity packages for maintainability. On the client side, we have the React Native application. So this is the React Native application. So it offers a clean, user-friendly interface where users can enter a property characteristics such as location, surface, area, and so on and so forth, and instantly receive an estimated rental price. This demonstrates the integration of AI into a full stack mobile experience. So now we will launch all the service and we will test our application. So let's start with the Python or the FastAPI service. So it runs successfully. Now let's run the Spring Boot application. As you can see, started also successfully. And finally, the React Native application. So we can test the front end via a web browser, or we can test it using XGBoost in our phone. I will drop also a video, or I will join a video which demonstrates the application in my phone, but let's test it in a web browser. So let's click on Estimer mon loyer. We should enter all those fields, and then we will click just on Prédire le prix for getting the price. And this is the price estimated, 1,081 per month. So to close the ecosystem or to close the loop, we have the data entered by the user. It's stored in the PostgreSQL database, as you can see, the data entered by the user and the estimated price. And then the PostgreDB is connected to Power BI to develop some dashboards for admin or for business users. So here it is, the dashboard. We have some visualization here. We have some KPIs, like the average of price, the average of charge locative, the average of surface, the average of depot de garantie, and some other visualization that I will let you to explore by yourself. To sum up, LebonPrix is a complete production-oriented system that bridges data engineering, machine learning, and application development. It automates every step from web scraping to data cleaning to model training, deployment, and business visualization. As future perspective, we plan to integrate additional data sources to reinforce our dataset of training, then experiment with deep learning architectures for higher accuracy, migrate to a cloud-native infrastructure for better scalability, and finally reinforce data governance and security mechanism. So this project showcases the power of a fully integrated AI pipeline capable of transforming raw online information into intelligent business values. Thank you. That should be all for this video. I hope you enjoyed watching this video. So be ready for the next one.